All right, so the recorder has started. First thing I want to show you, are the projects, that I have done so far, with Scratch. You can see that, there's a, spelling test. This is an app that I wrote. It's not an app. It doesn't run on an Android device. It just runs on a normal PC. So you start the program, and you click one of these bubbles, right? One of these dots. Each one is representing a word that my son was supposed to learn in 3rd grade. And this is all kind of randomized. So he has to, he cannot just guess, which one is which word. So you click one word. What is the spelling of the word you just heard? I didn't turn on the speaker. So we'll stop the program and run it again. Okay, there we go.
Carol brought some games to our party. Brought.
So, that's the word that he's supposed to spell. And if you spell correctly, then the bubble disappears. If it doesn't spell correctly, this bubble stays on the screen. So I think it's brought, right? Good job, that's correct. All right. So now the circle disappears. So this is what I wrote, just so that he can get some entertainment out of studying for spelling tests. The actual code is not really that hard. If you look at the source code, let me see, how do I get to the source code? See inside. And that's basically the source code on this side here. That's the source code. And I left a lot of comments, so that people who want to customize it for other words can do so. Each sprite is a word. So if you look at each one, it has basically the same program. But you can change the word and also re-record the sentence itself to suit whatever spelling test you're trying to get your kids to be ready for. Okay, nothing fancy. It's really just a simple application of what programming can do. This is the entire program. Let me shrink all the comments here. This side shows the program. So if I want to, let me just see if I can maximize. Yeah, there we go. So now I can show more of the program. Unfortunately, I cannot really zoom in. Maybe I can. There we go. So I can actually zoom in. And this particular word is cough. Okay. So my son has to spell cough correctly in this case. And this is the logic of the sprite. When this sprite is clicked, which means that particular circle is clicked, then it's going to go through this logic. If correct count is greater than 0, then it will go ahead and do the following, which is to play the sound, a recording of the word that he's supposed to spell, and then it will ask, what is the spelling of the word you just heard. If the word that he's supposed to spell is the same as the answer that he types, then I'll say, good job, that's correct, and then I will, decrement correct count by 1, and so he has to, if he missed the word, then it's going to the else part here, and it will say the correct spelling of the word is, something. It would actually spell the word out, but then it will hide it again. So the bubble won't go away until he can get it. Okay, so that's that's a very simple program. Doesn't really do a whole lot, and that's one thing. The other thing would be this one here. I brought along my mini-me. It's a Lego Mindstorms. It's a Lego Mindstorms. It's the old version. It's called the NXT. And it has a lot of, it's kind of clunky. So the processor unit by today's standard is really old, slow, and kind of clunky. But it is used a lot. Okay, so this one is kind of like the de facto standard, for middle school and high school robot projects. So that even newer one is not as popular because it's not backward compatible. So the tools and the knowledge that people have developed over the years just does not apply. Okay, so I'm going to put it here. And I wrote this app here, so if you look at the screen, this is an Android app. And I do it by the MIT App Inventor. Scratch is also done by MIT, okay, but a different team of developers. But the concept is really, really about the same. So in this case, I have a WYSIWYG viewer pane, which let me, drag and drop, all of these components into an Android, app screen. And let me get my phone here. Okay, So I got the app, the APK file installed on my phone. You can actually, if you want to, develop apps, turn them into APKs and sell, or have your apps be available on the Android Play market if you want to. It's actually capable of doing that. So this is the layout of the screen. The program itself is this. Okay, so right now it doesn't have a whole lot of logic. All it is doing is to send commands to the robot itself. The robot is Bluetooth enabled, so what I can do is I can run the app from my phone. And right now it doesn't do a whole lot. All I can do is to remotely control it. But I can actually build intelligence into the application too when I have time. So I'm going to run the app here. And first I have to pair with the device. Okay, now that it's paired, I can do some really simple stuff like making it just, turn like that. Okay, and I can make it go backwards, I think. No, I cannot because I did not.
Can you clamp it?
Hmm?
Can you clamp it?
No, not right now.
Yeah.
But it is connected to a motor, so the
Yeah.
claws are connected to the third motor. And there's a little sensor here.
Uh-huh.
That's a touch sensor.
Uh-huh.
So potentially I can have the logic, to monitor the status of the sensor. And when it is closed, then I can actuate, the claws and see if I can grab onto the object that bumped the sensor.
I was gonna say grab my water.
It also has, the kit also comes with 3 additional sensors. One to measure sound wave or sound level, just the amplitude. It cannot actually hear anything per se, but it can kind of tell you, what is the noise level, of the surrounding. There's a photo sensor, that can actually detect colors, and there's an ultrasound sensor that can detect the distance to an object that reflects in the ultrasound. So those things can all be attached. I've only used one of the 4 connectors for sensors. And all of those things can be connected. As I said, this brick here, this is the basically the processing unit on the robot itself. It's kind of dated. The processing power is limited, and certainly doesn't have the resources, like a phone or something that's a lot bigger. And that's why I'm writing the app on my cell phone, which has a lot more processing resources than this little thing here. So it can do a lot of stuff. The app that I'm writing here, it is also capable of connecting to the web. So if I want to, I can actually connect to the web and have my phone to act as a proxy so that someone can remotely control the robot over the web. That'd be kind of cool.
Away.
Of course, I have the kill switch, right? So I just wanted to show you, what you can do with this stuff here. And even with this particular screen, some of you may be able to recognize certain things that we have already talked about in this class. Like right here, you don't have to worry too much about, to blah, blah, blah. Just focus on the if-else block. That's our conditional statement. Let me just kind of point out which part of the screen I'm referring to. Okay. So this if-else test, this is the condition of a conditional statement. This block here is what I want the app to do when the condition is true, and this block here is what I want the app to do when the condition is false. Okay, so conditional statement right here. Okay, so I think there's a lot of potential. Okay, as you take this class. If you have an Android, mobile device, if you don't have one, that's okay. You can actually run it in an emulator, so you can actually develop your app without a physical Android device, of your own. But you can actually follow this class along, and actually test the concepts on an app like this or Scratch, and actually have some fun. Do something that is fun to you. The website has a lot of tutorials. If you go to learn here, just click learn. And by the way, the website is appinventor.mit.edu. If you go to tutorials, it has tons of tutorials that will basically guide you through the programming part step by step. And I think it's terrific. It's all free too. And you don't have to pay a single, you don't have to pay a dime. The only thing you need is a Google account, which you already have. Your W7 digit at apps.org losreals.edu account is a Gmail account. So you already have what it takes, to start to play with this. Okay. Any questions about this? No questions? Nobody's going to ask. I don't see how this is related to this class. Please don't take any more digressions.
Can we make this one of our projects?
Yeah. Can we do something like
nice.
this?
Okay, it'll be nice, but I think it is important for us to know what the program is supposed to do
Before we actually
let
make one.
somebody, let the robot to do it, right? I think letting the robot, let the program run so I can see what the program does. That kind of mentality is probably okay when you're dealing with a program that only has generate some output on the little text screen, right? But when the app is running on the robot, maybe that's not such a good idea. Maybe it will back up the robot and it will just fall and destroy itself. There goes a few $100, right? On the other hand, if you have a several billion-dollar robot that is armed to the teeth, and you just say, I think I'll just test the program and see what it does, that can be a very bad thing.
Did you build this too?
This is quote unquote a stock design that comes with the kit. So they give you step-by-step instructions to construct this particular robot. Right, it's just from a book that comes with the kit.
Oh, man. So
It's called Lego Mindstorms, and this one is the NXT version. It's probably one of the most popular version of Lego robots at this point, because there's a version before this and there's a version after that, and neither has gained nearly as much momentum as NXT. Yep.
Is there like other ones that are bigger than this one?
I think the kit has more stuff in it, but I'm not sure whether it is bigger or not.
But you can build like different ones with the same pieces.
It's Legos, right? I mean, Lego is Lego.
You can always
all the pieces that you have accumulated over the past 15 years, they will all fit. They will all fit. If you like that little horse head, from way back when, stick it here, it'll fit. Even the Duplos. If you have a younger, sibling, who's still playing with Duplos, you can stick the Duplos here.
Bionicles and everything.
Yeah, Bionicles. Oh yeah, everything. Star Wars theme. Oh yeah. Okay, so I think we talked about career GPS already, so I'm not going to talk too much about that. Except it's kind of cool to go through the assessment. I talked about this last time. Yeah. So I'm not going to take too much time to talk about this today. I spammed everyone, every single one of my students, not just in this class, but in all of my classes today with these guys. So I sent you a link that you can download. That's the IEEE Robotics and Automation magazine. Did anyone have a chance to take a look at it? You're just kind of flip through the pages? Kind of? No? Okay. Okay, it's... Sorry?
I downloaded
I started to, yeah.
Okay, you just have to flip through the pages. I'm not expecting anyone in this class to really read all of the paper, but you can at least get an idea of what kind of research is being done in robotics now, okay? It's not an academic, journal, but at the same time, it is still very tied into the research that is being actively done. So that's one. Spectrum Online Magazine is the other one that I sent out to the entire class, to all of my students. This one is just an e-magazine. There's not much depth in it, but it does tell you what is coming. Okay, the end of driving. You can definitely just read it by yourself. Autonomous cars to reach commercial viability by 2020. And you might think 2020, that's way out there. But wait, it's 2013 already. Okay, 7 more years. Okay, you just go, if you know someone who's 11 at this point, you just say, when that person can drive, can get a driver's license, that is reality. Okay, if someone is old enough in this class to remember, Kit Knight Rider, the original Knight Rider, with the swooping lights and stuff. You guys will remember he has a, the main character has a big watch thing. That's also his walkie-talkie. So he would call out and say, "Kid, pick me up around the corner," right? That's reality. It is reality now. In fact, it's better than science fiction now because you have your Bluetooth headset. You just tap it and then you say you say one word to get the prompt to get your computer to know that you're talking to it, and then you can just say pick me up.
Mm-hmm. Where
Google Cars is here. It's not 2020. It has been around for a long time. Google Cars have been around for a long time. So cars have been driving for a long time. It's just that we have not reached commercial viability at this point. Okay, they're just too expensive to be sold through a dealership. But it's going to be here by 2020.
And Tesla Motors is going to build it?
Right?
Oh, hold on.
Is it Tesla Motors is going to build it?
Sorry?
Tesla Motors is going to build it?
I think all manufacturers will jump on this bandwagon.
Elon Musk is going to...
Yeah, I think everyone is going to jump on this bandwagon.
Oh, yes.
Yep.
And Google car in Nevada had a driver's license.
Really?
Yeah, and driving and had an accident, but it wasn't the computer.
Yeah, it's the other party, right?
Yeah.
Yep.
Pretty cool.
And of course, it has everything recorded, right? So you can go through the whole accident frame by frame, and find out who's at fault. It's not the computer.
It's also legal to have driverless cars in California now, isn't it?
Yes, it is.
That's what I thought.
In fact, I went to a show, not a show, it's a workshop at the beginning of this year, and somebody in the workshop told me that he or she, I cannot remember, talked to a taxi cab driver. The taxi cab driver was worried that he will be out of a job because the first kind of vehicles that will be automated will be taxi cabs. Think about it.
Boy,
It makes
so much
perfect
more,
sense, right?
yes.
It makes perfect
Wow.
sense to automate of all cars, taxi cabs, especially in a busy place like San Francisco or New York City. Okay, so now you have basically taxis with no one inside, but using an app. Okay, using an app, you can just say, okay, I need a taxi, and the closest taxi cab that is vacant can just get to your place and pick you up. Think about that.
That's why I want to learn this. That's why it's...
So I think a lot of stuff is happening, and if I don't keep an eye on this, I would miss it. I would just completely miss it, right? I mean, I'd just be grading my exams and my homework assignments and not realize what is going on in the world. And then the last piece is not really that important to most people, but I think I'll just bring it out anyway. This is an article from USA Today that talks about the gender gap in STEM-related fields. Okay, STEM is science, technology, engineering, and math. So if you are interested in this, you can just go ahead and search for it. Just look for the title of Community College STEM and women. Okay, that's basically those are the keywords. Because if you just kind of look around, you can see that the gap is still here, but I think the gap is kind of starting to narrow a little bit over the years. When I first started to teach here in year 2000 in a programming class, it'll be lopsided. Not just lopsided, there will be like one gender is completely missing. Okay, and I think the proportion is now starting to increase, which is great because otherwise we'll be missing one half of the population, as potential employees in this field. Okay, so that's it. All the kind of relevant but not directly relevant stuff. Yep.
Roll sheet.
Roll sheet. Thank you. And you guys know that you can add to the class now, right? I think I talked about that last time on Tuesday. So if you have been waiting to add to the class, you can now add to the class. The dean has said that he will sign the paperwork all the way up to tomorrow. Okay, so don't do it any further. Don't do it any later than tomorrow. All right. Thank you for the reminder. And now we can get back to the kind of boring but kind of important stuff. Pre and post conditions. And last time we already talked about how to use the substitution rule. So today we'll focus on the other rule. What if the operation on the right hand side is not reversible? I will backtrack to where we left off last time so that we can just kind of reestablish the context of this discussion. Okay, so the discussion has to do with this. Okay, let's say this is line 11, And on line 11, x gets 2 times x. Okay, that's what line 11 is going to do. So the way we look at this is, okay, we'll generalize all the assignment statements into just the line number. So in this case, the line number is easy. It's just line 11. This is the left-hand side, which is always a variable, something that can change. And the right-hand side is the most important part. We'll generalize this as a function of x. So we call it f of x, right? Okay, so that's what we talked about last time. And what we're really interested in is, okay, in this case, the right-hand side is 2 times x. So we'll just call that f of x, and we'll just repeat the same thing. That by itself is really just a symbol. I'm using a symbol to represent the right-hand side, okay, f of x. Now, by the way, f of x as a function does not always have to involve x. F of x can be 0, okay? And in that case, it's basically mapping all values of x to a single value, which is 0, okay? So that part is not really that interesting. The interesting part is, the big question is, okay, I'm going to say the big question is, does f of x, or does f have an inverse? That really is the big question. Can I undo whatever the right-hand side is doing to x? In other words, the change due to line 11, can I undo that change? If I know the result, can I undo it? That's the big question. And the answer is, well, it depends. Okay, sometimes we can and sometimes we cannot. In this case, we can. Okay, so if f of x, okay, if f of x is 2 times x, then f prime, in this class I'm using f prime to denote the inverse function of f, which is not conventional. But since I'm using a text editor, that's all that I can do. Okay, dividing something by 2 is the same as the reverse of doubling something. It seems to make sense, right? So this is important because if f prime exists, then we can use the substitution rule. The substitution rule is basically saying the post condition of, in this case, line 11, is based on the precondition of line 11. But I'm not just going to copy and paste the precondition of line 11. I'm going to look for all occurrences of x, and in this case, x is the variable on the left-hand side of the assignment. And I'll replace every single one of those with f prime, the inverse function, not the function itself, but its inverse, applied to x. That is something that we can do if the right-hand side is reversible. Okay? But this is big, because what this allows us to do is to maintain the relationship between x and everything else so that the post condition is just as informed, is telling us just as much, not any less than the precondition. Are we doing okay so far? Okay, so we'll go through one example in this case. So in this particular case, okay, let's assume, in this case, let's say the precondition of line 11 is, let's say it is just, x is less than y, and x plus 3 is greater than k. Okay, don't ask me why. It has to do with the 10 lines before that, or if this is a part of a loop, it has to do with the rest of the loop as well. So I'm not going to say why the precondition is like this. I'm just telling you that this is guaranteed to be true when I execute line 11. So the post condition in this case, I'm just going to copy and paste this part here, because this is the template. This is how we apply the substitution rule. Now the second line is going to be a little bit tedious, because all I'm going to do in this case is to replace the precondition with the actual condition itself. We have x here, and then f prime is replaced by x divided by 2, because that's the inverse function of 2 times x. And then the third step finishes the entire operation, because what the third step is going to do is to take the precondition itself, and then every time I see x, I replace it with x divided by 2. Everywhere I see x, I replace it with x divided by 2, and I'm done. Okay? This is useful because if someone tells me something about the precondition of line 11 in this case, I can now say what has to be true after line 11 executes. That can be very useful because you can keep doing this and push the post condition forward until you get to the end of the entire program. Are we doing okay so far with the application of the substitution rule? Now the application.
X is
sorry?
less than y and x plus 3 greater than k. Where'd you get that?
It came from here. The precondition states, x plus 3 is greater than k, and I'm substituting x with x divided by 2. But did I misunderstand your question? Okay, were you asking how I knew x plus 3 is greater than k?
No, the 2 lines before.
Two lines
assume
before.
11 and not that whole line.
That whole line?
Yeah.
It's just an assumption for no particular reason. Because we are right in the middle of an entire program, analyzing an entire program. I'm focusing on line 11 at this point. So the lines before that, the previous 10 lines, for whatever reason, because of their the structure of that code, is guaranteeing that by the time I get to line 11, x is less than y and x plus 3 is greater than k has to be true. So that's basically how it came about. It's just I'm just randomly throwing something up there. The part that is not random is how we derive the post condition from the precondition. So the precondition, yes, it's kind of random, but the post condition definitely is not. Okay. Are there any questions about this part of the pre and post conditions? Okay, so this is what we talked about last time, and what we'll do this time is to say, well, the application of the substitution rule hinges on the existence of the f prime, of the inverse function of f. So the question is, what if we don't have an inverse function? Well, then we have to use the other rule. Okay? If an inverse function does not exist, then we have to do something else. Okay, so before we discuss what else we're going to do, let's go through another example where there's no inverse. Okay, so this is line 41, and let's just say that on line 41 x gets the value of another variable. Let's say that's y. Okay, and that's the statement on line 41. Let's also say that the precondition of line 41, once again, don't ask me why this is the precondition. I'm just using it as an example. So as an example, we have this, and it states that x is greater than z. That's guaranteed to be true before line 41 executes. It's also guaranteed that y is 2 times k. Okay. And we also know that, I don't know, k has to be, k cannot be 0. Okay. That's all the stuff that we know at this point. Okay. The question is, what are we going to do about post 41? I cannot apply the substitution operation because there's no way for me to undo the operation. Because after line 41, x is going to have the same value as y. But I cannot reverse that operation. I cannot say, oh, now that it has a value of y, it means it must have this value before line 41. There's no way for me to reverse that operation. So that means the post operation cannot be a substitution operation. I call this a forget operation because we basically have to ditch certain things about the precondition. So I use this word here to say we are forgetting something in the precondition of line 41. What are we forgetting? Everything that we knew about x. Okay? But we can also add one more fact after we forget everything that we knew about x, because the one new thing that I know about x is x equals to y now. Is that making any sense? Now this is a generalization. Okay, the forget rule is kind of a generalization. It works most of the time, but occasionally, depending on what is pre-41, you can still get to retain a little bit more than this. Okay, but for this class, I'm just going to say, well, just forget everything that you knew about x, because we are changing it in a way that is not reversible. Okay, so what do we do when we apply the forget operation? Well, the first part is easy. The first part is really just spelling out what is the precondition of line 41. Okay, so I'm just expanding one part of the equation here. And then the next step is even easier, because what I'm saying is, well, wherever I mention x, just get rid of it. Okay, so in this case, x is greater than z, I'm going to get rid of it, because that is no longer guaranteed. So now it becomes just y equals 2 times k, because that does not mention anything about x, so I get to keep it. K is different from 0. I can keep that too, because the assignment statement on line 41 does not affect k, so whatever I knew about k is still true at this point. And the new fact that I know about x is x has the same value as y. Now, at this point, you can choose to whether to expand this or substitute this with 2 times k is entirely up to you. But because they're both referring to variables, there's no gain one way or another. All right. Are there any questions at this point about the forget operation? So if you cannot find the inverse function, use the forget operation. But if you can find an inverse function, then use the inverse function. Okay. Any questions? Yep, go ahead.
Why not? Like, why is either the f prime or forget?
If f prime, which is our inverse function, exists, then you do not use the forget rule. In that case, you use the substitution rule, because you can maintain the relationship between the variable that you're changing and how it relates to everything else. You just have to change it a little bit. Okay? But if the inverse function does not exist, then you can no longer maintain the relationship between the variable that you're changing with the rest of the entire program, with all the other variables and constants.
Is it a mathematical rule?
It's not a mathematical rule. The forget part definitely is not a mathematical rule. It just works, in most cases, because you have to get rid of the components that mentions anything about how x relates to other variables, because those cannot be guaranteed anymore. Now the forget operation sometimes will get rid of more information than you need to. So it's not a very general kind of rule, but in this class we'll just say, okay, we'll just go with the forget rule. Okay. Any questions at this point? So you guys doing okay? Any questions? Go ahead, you can ask.
That's okay.
All right. Any other questions? No other questions?
Are there any more complex examples of something that wouldn't have an inverse function for it?
The inverse function?
Or, is there any more complex? Obviously, if it's just x gets y, that's obvious, but is there anything more?
X gets, x minus x has no inverse, because x minus x is always mapped to 0. X gets x squared technically has no inverse, but you can express it in 2 ways, because you can say, x, you can use the negative of the square root and the positive of the square root, but you have to split it with an or, because you don't know which one it was before the square. Yep. Okay. Any other questions? Okay. If there are no more questions, we'll go ahead and apply some of what we have learned to a multi-branch conditional statement. In fact, even a regular conditional statement will work, but a multi-branch conditional statement is even more interesting in this case. So we'll go ahead and take a look at how to analyze a multi-branch conditional statement. Okay. So in this case, I'm just going to go a little bit easier and just say, if x is less than or equal to 0, then we'll do something here. The branch itself, I'm just going to make it very simple, okay, because that's really not the main point of this discussion. Else if x is greater than, let's say, 7, then line 4 is going to say z gets 1. So as I said, the branch itself is not interesting. It is the condition that is interesting. And on line 5, I will say else if x is less than 20. Then on line 6, we'll say z gets a value of 2. And I think that's it. Okay, so on line 7, we have an else. On line 8, we finally have a z gets 3. On line 9, it is and if. So this is the little pseudocode that I'm going to analyze and try to figure out the pre and post conditions of everything. Okay? And in this case, let's just say that I do not know anything about x beforehand, so the precondition of line 1 is just true, okay? Because I don't want to state anything about x. So it doesn't seem very difficult. I mean, in this particular case, you can actually trace it, okay, with different values of x and try to see, which branch, you can get into. But we can analyze this without throwing a single test case at it and say, oh, you know what? Line 8 is a dead branch. There's no way we can get to it. Okay? So let's go ahead and see, why, line 8 is a dead branch and what is the indicator that that is a dead branch. Okay, so we'll go ahead and just do our usual stuff. So we'll take a look at pre-2. Okay, in other words, I'm about to execute line 2. What do I know for sure before I execute line 2?
Is less than 0?
Technically speaking, we have to say pre1 is still true, because that's I did not have a chance to change anything. So pre1 still has to be true, and then the condition x is less than or equal to 0 has to be true, and that becomes true, and x is less than or equal to 0, and that simplifies to just x is less than or equal to 0. Okay, is that making any sense? In other words, every time in this particular pseudocode, if I'm about to execute line 3, excuse me, every time when I'm about to execute line 2, I know that x is less than or equal to 0. There's nothing really mysterious here, okay? Because that's the way a conditional statement behaves. Okay, I'm not even going to bother with post 2, because that's really not the main point of this discussion here. Let's take a look at line 3. Line 4, excuse me, the precondition of line 4. Okay, so the precondition of line 4 is telling me this has to be true if I am about to execute line 4. Okay, so if you remember the picture of a multi-branch conditional statement, you probably can remember that at this point, if I'm about to execute line 4, I do not have a chance to modify anything just yet. So that means pre1 still has to be true, just like it has to be true before line 2 executes. What about x is less than or equal to 0? Should I do something about that or not? Okay, let me ask the question in a different way. Can we say anything about x is less than or equal to 0? Okay, you get 3 choices. 1, I cannot say anything about it. 2, it has to be true. 3, it has to be false.
Has to be false.
Has to be false because this is a multi-branch conditional statement. If I'm about to execute line 4, that means x is less than or equal to 0 has to be false. Okay, we'll say that. That's easy to say. Okay, and what else has to be true if I'm about to execute line 4? X is greater than 7, right? Because that's the condition corresponding to this particular branch. Okay, well, we'll go ahead and expand all of this stuff here. There's a lot of typing. So this one, I'm just going to reverse it to x is greater than 0 because it is not the case that x is less than or equal to 0. Simply means x is greater than 0. Okay. And we already know that we can get rid of the true and something because true is the identity of conjunction. So we can get rid of that. And now we have x is greater than 0 and x is greater than 7. Can we simplify this a little bit?
Yes.
And the conclusion would be
X greater than 7.
x is greater than 7 because this is a conjunction. We choose the more restrictive one when there's a conjunction. But the requirement is one has to contain the other one entirely before you use that rule and say, oh, we'll just keep the one that is more restrictive. Because if these two are not, one does not contain the other one completely, then you cannot just say, oh, we'll just choose one of those two. Okay, so in this case, it simplifies to x is greater than 7. Okay, that's good. No big deal. I'm not going to bother with post 4 because you can see post 4 is pretty easy. It's whatever pre 4 is, and then plus z equals to 1. So I'm not going to even go there. Let's take a look at line 6, pre 6. Well, I think most of you are getting the pattern already. Pre 1 has to be true. The condition of the first condition, the condition of line 1, has to be false. The condition of line 3 also has to be false, right? Because otherwise we wouldn't be here. But the condition of the of line 5 has to be true. So we now have this kind of rather long conjunction here. This is just true. No, it is not the case that x is less than or equal to 0 means x is greater than 0. We knew about this one from the case before. It is not the case that x is greater than 7 means x is less than or equal to 7. And the last one is x is less than 20 itself. We'll go ahead and do one simplification at a time. So right here we get rid of the true. We have this part left. And x is less than or equal to 7, and x is less than 20. Okay, can I simplify this any further?
X is less than or equal to 7.
X is less than or equal to 7, exactly. Because if you look at these two conditions, if you look at these two comparisons, x is less than or equal to 7, and x is less than 20, one completely contains the other one. If you draw this out on the number line, you will see that this one is more general because it includes a little bit more number, and this one is more restrictive. And because one is contained within the other one, and this is a conjunction, we can choose the restrictive one and simplify the whole expression. Okay.
Just, so I make sure I'm understanding clearly. What you're doing is you're going through each particular line, and then you're saying in order for this condition to be ran, everything has to be true, and then everything we have to lay out all of the
conditions before this line has to be false, but the one right before this line has to be true.
Right, and then you're working the
it's just a pattern that we are going here. So we only have one left, okay, which is line 8. So we'll take a look at the precondition of line 8. It really is just getting tedious, right? Because we're just negating the conditions of all the lines before in this case. Okay, so we have not x is less than or equal to 0, not x is greater than 7, and not x is less than 20, which doesn't seem very difficult. I mean, it doesn't seem harmless, right? So this is true. This one is just x is greater than 0. This one is x is less than or equal to 7. And this one is x is greater than or equal to 20. I'm just flipping the not so that I get rid of the negation. Are there any questions at this point? Okay, no questions? Go ahead.
For future reference, if we were to do this on homework, how would we format it on LibreOffice?
If I have homework assignments like this, you can just use a normal text editor for that, so you don't need to use a LibreOffice for it. Because when you do a trace, the chances of two submissions being identical is pretty high, okay, especially if both are correct. But for something like this, it's pretty slim that people would do it exactly the same way, choosing the same order of doing things. So you can just use a text editor for that. Okay, all right. So let's go for simplifications here. I'm going to choose to group the greater than and the greater than or equals to one side. And then we have one less than or equal to on the other side. So this way we can do the simplification. All right, so let's do the simplification of these two guys. Okay, x is greater than 0, x is greater than or equal to 20. Which one is more restrictive? Greater than or equal to 20 is more restrictive. Okay, so we can just simplify this whole thing to x is greater than or equal to 20, and then we have the other one is x is less than or equal to 7. Give me a value that will fit this requirement. There's none. Okay? So what do I do with this expression? What do I do with this? It's simply false. Okay? It is false for all possible values of x, and therefore the expression is just false. Wait, now we have a precondition that is false. Right? So what it means is if a particular statement has a precondition of false, it means it's a dead branch. There's no way you can get there. Are we doing okay so far with that concept? Yep, go ahead.
On pre-2, why did you do at the last part where you showed x is greater than or equal to 0, which is equal to x is greater than or equal to 0? Why did you do that last part? Why didn't you just end it at the true?
On pre-2 here?
Yeah.
Okay, let me regroup this, using new lines.
Oh,
So this
okay.
way it will look a little bit more clear.
That makes sense.
okay.
I was just lazy.
That helps.
I was just lazy. The enter key is too far. My pinky cannot get there. There you go. Sorry about that. All right. So here, yeah, go ahead.
So on pre-6, so on pre-4 ends with x is greater than 7. On pre-6, you follow through on the second line, true, and x is greater than 0, and then x is less than or equal to 7.
It comes from the negation of x is greater than 7.
Okay.
Because in order for me to get to line 6, the condition of line 5 has to be true, but all of the ones before, they have to be false in order for me to follow the multi-branch conditional statement to get to that point. Is that okay?
Yeah.
Okay. Now, the big question is, who would write a stupid program like this with a dead branch, right? I mean, why would you do something like that? I mean, it's just not smart. Well, it has nothing to do with smart or stupid. This has to do with feature creep, which is a term to refer to information systems where the requirement is not really clearly spelled out from day one, and it keeps changing and changing and changing. And also, changes that is outside of the information system that necessitate modifications to the program. Think TurboTax. Okay, pretty sure if you have not used TurboTax, you know what it is. It's a tax preparation program. For the rest of us, most of us, we can do a 1040 easy, right? I mean, because we just have a single when we have a stable income source that is regular, all the deductions are already done, so it's easy to do. But if you look at the tax rules, how thick do you think that book is just for California tax rules? It's pretty thick. I mean, there are a lot of exceptions, right? If you're this and that, but not that and that, then special exceptions apply to that particular case, right? Does that remind you of this kind of stuff? So there are times when programs just evolve over time, and we're just adding more and more and more exception cases. And the ordering of the exception cases now matters, right? Because if I flip the order of these conditions, it will change the behavior of this algorithm. Okay, it's possible, it might be possible, I'm not saying that for sure. Let's see, if I order this, there's no way I can order this to make line 8 reachable. Because no matter what I do, in order to get to line 8, the conditions of line 1, 3, and 5, they all have to be false. And if those conditions are all false, there's no way I can find an x to fit through this. Okay, but there are cases where by reordering the cases, by reordering the conditions of line 3, 1, 3, and 5, it would change the behavior of the program. Okay, it would change the location of the dead branch. Okay, you can move it forward, move it downward, and so on. With this one, I think there is a way to create one additional dead branch. I can kill one more branch in this case.
Is there any uses for dead branches?
No, dead branches are they're not only useless, it's actually bad, because if a program is written like this, it means that somebody thought that z should get a value of 3 sometimes. Okay? But in reality, it will never get a value of 3. So if the rest of the program, for whatever reason, depends on the fact that x has a value of 3, those would also automatically become dead branches.
So ruin the whole thing.
So you have dead branches propagating,
Dead branches
throughout the
that tree
program.
trunk to tree.
Yeah, it becomes infectious, right? It becomes an infection of the tree.
Is that how you make like a virus or something?
No, well, if you want to know how to do that, you have to take cisp300,
Oh, okay.
which I teach.
Oh, nice.
And nobody can get out of this college with a transfer degree without taking P310. So I will see most of you again.
Yeah.
Okay, so are there any questions about this particular example?
Can you scroll down? I just wanted to write the rest down.
Oh, absolutely. There we go. Yeah, the detail is important, but I think it's the big picture that is also important. Okay? Because the other way to find out that line 8 is a dead branch is to keep throwing dots at it, right? And then you say, how come I cannot hit line 8? All of my dots are missing line 8. But you can throw 20,000 darts, they all miss line 8, and it doesn't guarantee the next one will also miss line 8. So you have to keep throwing darts until there are no more darts, until your time runs out, basically.
It's a very big
But
brute force program.
if you analyze a program using mathematics, step-by-step proofs, I know for sure line 8 is not reachable. Done deal. Okay? So it's the approach that is important. It's not so much the steps and the Boolean algebra that I use. Those are mechanical. Okay? But it's what I'm trying to accomplish that is more important. Yep.
In the pre-8, on the second line, why did you put x is greater than or equal to 20?
On the second line of
Pre-8?
Okay,
Pre-8?
pre-8. On the second line, why do I say
X is greater than 20?
x is greater than or?
Because it's the falsified.
Because this turns into that.
Oh, x is less than.
Yeah,
So
it's greater than
So
or
it's
equal
not
to
less
20.
Than 20. It has to be greater than or equal to 20.
It's just another way to say
Say
it is
that.
not
Okay.
less than 20. Normally, I flip the polarity because it's just easier to look at comparison by itself rather than a negation on a inequality. All right. Any other questions about this particular derivation?
Is that gonna be our next homework?
Yep. Next homework is gonna have something
Another
like
example?
this.
Can we do another one?
We'll do one kind of fun one. Okay, we'll do one that is going backwards, but with a conditional statement. Okay, so we'll take a look at this one. Okay, it's kind of interesting. I don't need to invent strange line numbers. I'm just gonna go with 1, 2, 3, 4, 5 in this case. Okay, so let me see. I have to kind of think about this first, and then we'll go ahead and do it. Okay, so this one starts with if x equals 5. Then on line 2, if x equals 5, we will go ahead and subtract 1 from 5, from x, which must have a value of 5 at that point. And then on line 3, we have the else. On line 4, we have the actual branch here. And let me think about this. Okay, so in this case, we can say x gets x plus 1. Okay, there we go. And then on line 5, we have and if. So we have a fairly simple conditional statement. All the assignment statements are reversible. The condition is pretty easy. It's just x equals 5. Okay, it's pretty solid. And I'll give you the post condition. Okay, so the post condition in this case, post 5, is x equals 4. That's my post condition. Okay. I want to reverse all of these steps back to pre-1. In other words, if I can observe the program, I ran this program, and on line 5, or on the line after line 5, I observe that x has a value of 4. Yep.
Or do you want to answer?
Sure, go ahead.
I'm guessing it's x equals 5. And then
X equals 5
post
is a part of the answer. So that's very good. Okay, you were able to track down one path through the whole thing, but there's another path to go through this whole thing.
And just to make sure, so we're understanding, like how we've been doing, like these other things, we're just doing it backwards, right?
We're doing it backwards, exactly.
So then, wouldn't the next one be post 2 is,
Okay, so
you know,
I think it really helps if we can just draw a picture about this. Okay, so I'm gonna draw this on the whiteboard. You know, I didn't bring my Elmo. I should have brought it. But instead I brought the stupid robot that doesn't do a single thing in the class.
It's a cool robot.
Okay, so we have a conditional statement. Okay, very familiar shape by now, I hope. Okay, so here we have a conditional statement corresponding to what we have on the whiteboard. We have x equals to 5 as the condition. This is the true branch. This is the false branch. The true branch will go here and say x gets x minus 1, and in the false branch, the else branch will say x gets x plus 1. And here we have post 5, which says, oh, you know what, at this point, for whatever reason, x equals to 4. It is a confirmation that x has a value of 4. It's not a question whether it is 4, okay? It's observable. All right. So the question now is, I want to reverse this whole thing so that I can go back to line 1 and say the precondition of line 1 has to be this. That is a condition that must be true, okay? And guess what? This is a debugging process, okay? Because whatever you're observing here may be a condition that should not happen. So what you need to do is to figure out how can my program get to this point and have the wrong value in x. And that's why we are doing it backwards, okay? Okay?
Can you see the inverses or anything?
Okay, so what we want to do is to say, all right, at this point x has a value of 4, but I could have come from either branch because it's a conditional statement. I have no idea which branch I took to get here. I know I took one of the 2 branches to get here. So the first thing I'm going to do is to say, maybe the post condition of line 2 is also x equals 4. Maybe the post condition of line 4 is also x equals to 4. Okay? Those are entirely possible. I mean, it doesn't say that it has to be only be one of them, right? So if I just write down here, I'll just say post 4 is x equals 4, and then post 2 is also x equals 4, because if both of these are representing the end of a branch to get to the point where I can observe x has a value of 4. Are we doing okay so far? I'm trying to trace my way backwards. Okay. Yep.
Does that mean precondition 1 could be x equals 3 or x equals 5?
That's right. Yep. But we're going to go through this, to kind of flip backwards. Okay. All right. Knowing the post condition of line 4 is x equals 4, we try to figure out what is the precondition of line 4. Okay. So in the picture, we are talking about this part here. X equals to 4 after we increment it. So before we increment, what should it be?
3.
Wow, good job. But that's exactly the way you approach it. Okay, you just approach it by looking at the post, operate the post condition, what we are doing to it, and then you just say, oh, okay, we can reverse that. So before the condition, x must have a value of 3. Okay. And we can apply the same logic and say, what is the precondition of line 2?
Must be 5.
X must be 5, because we just subtract 1 from x and then it became 4. Okay, very good. Now here comes the really tricky part. Okay, the tricky part is, does this condition fit x equals 5 is true? Because if it doesn't fit, that means I could not have come from that branch. Okay, am I getting this across? Okay, so let's go through this. is x equals 5, knowing x equals to 5, fit the condition of x equals 5 is true.
Yes.
Yeah, it fits. Okay, so that's one way to get it. Okay, x equals 5 is one way to get us through this branch to the exit here with x equals to 4. So now we have to go to the other side and see whether it is fitting or not. So when we go to this side here, we say, okay, we know that if we reverse the operation, at this point x must have a value of 3. So the question is, but if x has a value of 3 at this point, would we have taken this branch?
Yes.
In other words, is x equals to 3 consistent with x equals to 5 is false?
Yes.
Yes.
It is. Okay, so that means that is also a possible way to get back to the beginning. So now we have x equals 5 and x equals 3, but these two are both possible cases. So that's why we put an or here to say that that is my precondition. That's the math way of saying or. And the lazy way. Yep.
What if we were never to assume that post-condition 4 was x equals 4?
Say
That-
again?
What if we never assumed that post-condition 4 equaled x equals 4, and that the only condition we had was post-5 equals x equals 4?
Well, you have to start with something, right? So you can tell me something. So go ahead and invent your own post 5, and we'll try to work our way back.
I was just wondering, because if we only had post-5, then we wouldn't know whether or not x equaled 3 in the beginning or x equaled 5.
That is correct. We would not know. So what happens when you're debugging a program, and as you trace backwards, you say, oh, there are two ways to get to this point. But I know in this case, x can be 3, x can be 5 in order to get to that point. So that means I can propagate this, backwards, continue to go about doing this, and the more I go backwards, the more disjunction I will end up with, because there are more and more and more possibilities that will lead down the same path. Now, when you're actually debugging, what are you going to do? In other words, okay, let me give you an analogy of automotive diagnosis, okay? And don't tell AT around here that I'm teaching you this stuff, because they'll think that I'm stepping over their lawn. Turf war. Okay, so let's say your car could not start, okay? There are many reasons why your car would not start, right? So let's say it cranks, okay? You turn your ignition, it goes wah, 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 and there's nothing, okay? It just doesn't start, okay? What are you going to do?
Check the air, gas.
Okay, so there are many requirements, right? In order for your car to ignite, for the spark to, for the engine to do the combustion, it has a lot of requirements, okay? Now, assuming you don't have a diesel, which actually simplifies the whole thing a little bit. So if it's a gas engine, you need a spark, you need the right timing, you need air, and you need fuel. Okay, so those are the 4 basic things that you need in order for a gas engine to operate.
And then ignition. Ignition.
But missing any one of those will lead to the engine not starting. Okay, so if I look at a picture like this, it basically, is starting with a condition of engine not starting. Okay, you can also say, and it cranks. Okay, so you can at least make sure that your starter motor is okay. Okay, and all the mechanical linkage from the starter motor to the crankshaft is also okay. So you can rule out a whole bunch of possibilities right there. But in order to get to this symptom, we have a whole bunch of conditions that can get to here, right? Okay, no spark is one way to get to here. No air is one way to get here. No fuel is one way to get to here. So once again, guess what? We have the ors. Okay? So now the question is, as a automotive technician, what are you going to do next? Well, you can inspect all of these things, or you can run experiments, right? So for some of you, you already know that you can check whether the spark plug cables are good or not. There are ways you can check it. Okay, and basically when you check that, it's an experiment. Okay, because it has two possible outcomes. One outcome confirms that you have spark at the spark plug, and the opposite outcome will say that no, there's no spark at the spark plug, so you should fix that first. Now, just because you confirm there's no spark doesn't mean that there's air or fuel, because you can be missing all three components. Then you have a real lemon. But it is possible. And it's the same way here, okay? If the program is faulty because it has a value of 4 as the post condition of line 5, and you reverse the steps, and then you say, oh, before line 1, I know x must have a value of 5, or it has a value of 3, then you have to design experiments to find out which one it is. But because in this case, it cannot be both, okay? In the case of automotive engine, yes, you can miss all of these components at the same time. But because x is 5 and x is 3 are exclusive of each other, you know that it has to be one of these two. So what you need to do is to run the program in a certain way so you can confirm which way it is. Or if you want to analyze the program any further, you can just say that, oh, this is the post condition of line 0, and then push your way back to the earlier lines. So those line numbers will be negative in this case, because I started with line 1. But you guys see what I'm trying to say, right? I mean, this is developing a skill for you to analyze a program by looking at the program and reading it backwards. Yep.
In terms of how we would write that out, how would you write something like this out backwards?
Okay, in an exam, if I give you questions like this, the going backwards part is casual. Okay, you just have to kind of casually go through the the steps. But then what I would ask you to do is to go forward with this as a precondition of the whole thing, and then going forward, you have to use the formal steps. Okay, you look at x gets x minus 1. This is the function f. It has a reverse, it has an inverse function, and then you have to use the substitution rule, blah, 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 blah. So you do have you have to use the formal steps to go forward, because the whole idea is, if this is correct, you should get back to this post condition when you go forward again. Yep. Question? Okay.
You explained with the engine. I get that. I don't get the x equals 3.
You don't get the x equals 3? Okay.
Line 1, if x equals 5, then you get all the
okay, there's
the other
one.
lines. Why not x equals 3? Why not? It can be x equals 5 only. Why is it supposed to be x equals 3 too? Why do we have two answers here?
Okay, okay. The easy way is to trace it to confirm it. Okay, so forget x equals 5. Let's say x has a value of 3 on line 1. What is going to happen in this case? You go through this conditional statement. You say, does x equal to 5? No. So you're not going to follow the then branch. You will follow the else branch. So you follow the else branch here, you will get to this statement. X has a value of 3, so when you add 1 to it, it becomes 4. When you get out of the else branch, by the time you exit the conditional statement, x will have a value of 4.
Okay, so we should add, I guess, x equals 3 to line 1 too, right?
To line 1.
Yeah, because it's only x equals 5.
No, but that's the, okay, what you see in the pseudocode, I'm just going to highlight it. That is the program itself. That is the program itself, but this is a derived confirmation of the condition that must be true before line 1. Is that okay?
Okay, I'll get it, baby.
Okay, let me give you another example that kind of have a split like this too, but this one is really a lot easier. But it will illustrate the same kind of concept. So this one I can just say line 67, and I'll use square. Okay, so x gets x times x in this case. And I'll tell you the post condition of line 47. Okay, let's make it really, really simple. Use concrete values in this case. So let's say I know that x is 64 right after line 67 executes. What is the precondition of line 67? It seems to be very simple, but there's a little twist to it. So before line 67 executes, what must be true? Now, okay, most people would get this one, right? Because line 67 is going to square it, but you're missing the other possible case. because if x was -8, the square of that would also come out to be 64. That's basically what we are talking about. There are different values in a certain variable that can give exactly that can get me to the same conclusion as opposed to conditions.
So there'll be two answers on an exam if you're working backwards, pretty much.
It is actually it's one answer. This is a single precondition, and so is this one. It is a single precondition.
There's just two values for the answer.
It's just that it's just that the precondition is a disjunction expression instead of the usual conjunction expression. Okay.
I guess
So,
Oh, sorry.
So you were saying earlier, then there's no formal way to do a reverse trace, but so you'll just ask for an explanation on a test and for a reverse trace, but then you'll be asked to do a formal trace for doing it forward.
Yep.
Okay.
Not a trace, but a formal derivation. It's basically a mathematical derivation going forward.
Yeah, I guess I understand. So that's okay to get that answer, right? I mean, that's
Right.
okay, so-
But if you miss, one of those, two branches, then I'll take ones off, even though it can get to the same conclusion, but you're missing one possible way to get through that code and still come to the same conclusion. Yep.
So on this one, if we were doing the formal trace forward using the pre-67, because this can't have an inverse function, we would use the forget rule. So how would we get back to x?
No, this is,
Or there
yeah.
is an inverse, sorry.
it has no inverse, but basically what you can do is to have a split, instead of,
Substitution.
yeah, because you know what the possibilities are, so you can basically go back and say, well, it's either this or that.
Okay.
Because in the case of a square, there are only two cases, the plus and the minus of the root. So in that case, you can just express it as or. Use an or to split all the cases into two parts. But there are cases like, if the right-hand side is 0, there's no way you can do it because it maps every single value into 0. So there's no way to reverse that. That's a good question. All right. Any other questions? Okay. How many people are starting to hate this math stuff? It's a trick question, right? I mean, well, I personally think that I might have gone a little bit overboard on some of the math stuff. At the same time, there's nothing here that is really, really tricky. Okay, I think once you get the hang of the mechanical stuff, like the expressions and Boolean algebra, which are basically just rules, right? I mean, you see this, it's equivalent to that. If you see this, it's equivalent to that. The general idea is not really that complicated or difficult. It's just, how do you put pieces, together? I think that's really the most important part. Yep.
Yeah, on the material online, you also offered an alternative approach, which is actually proving it backwards. Following all the conditions all the way to the pre,
Yep.
which is really interesting. In cases where you cannot eyeball the answer right away.
Then you have to formally go through the
Yeah.
steps. Yeah. But I found that most people, if I start to talk about that, they will confuse those steps or skills with the skills that you need to go forward because they look almost exactly the same, except in one case you use f of x, the other case you use the inverse of f.
Yeah.
So that's why I don't talk about that anymore. But I'm kind of glad that you watched the old videos, to figure out how I
Actually,
explain
when
that.
This material it has an alternative approach.
Yep. Go ahead.
I don't really see a tie between going backwards and going forwards yet. Is there any way to show examples doing the same problem going backwards?
Well, let's go ahead and go forward with this one. Okay, if this is a precondition, using the structure of a conditional statement, I know what is pre-2, right? Pre-2 is going to be pre-1 and the confirmation of the condition itself. Does that make any sense? Because this is going forward. Okay, so I'm saying that let's say for whatever reason I know the pre-1 is x equals 3 or x equals 5. So now I need to go forward, and hopefully by the time we get to post 5, I get the same result, which is x equals 4. Okay. All right. So the pre-2, has to be like this because between line 1 and 2, I don't have a chance to change anything. So pre-1 still has to be true, but because I'm about to execute line 2, that means x equals 5, which is the condition of the conditional statement, also has to be true. So now I have something that looks exceedingly complicated, like that. Okay. So when you look at the two sides of the conjunction, one side looks like this, the other side looks like this. Do you think one side completely contains the other one, or one side is contained completely by the other one? One side has one dot, the other side has that one dot plus another dot, right? So which one should I choose, as the simplified version? X equals 5. Okay, so that becomes pre-2. And once we have pre-2, we can now go through the what we just learned earlier in this class. So we basically say the right-hand side of line 2 is f of x equals to x minus 1. It has an inverse. F prime of x is x plus 1. We use the substitution rule because it has an inverse. So the substitution rule goes like this. The post condition of line 2 is the result of applying substitution to pre-2, the precondition of line 2. We apply that to all occurrences of x, and every time I see an x, I will replace it with f prime applied to x, like that. So this is the general template. But once we get past the general template, then we can say, what is pre-2? Oh, pre-2 is pretty simple. X equals 5, and this is x. F prime of x is x plus 1, like so. So now I can actually carry out the substitution. So now it becomes x plus 1 equals 5, because I just take this x here and say, I'm going to replace it, substitute it by x plus 1. So now I have this conclusion here. And if you do one little step of algebra, you will get x equals 4, because if you subtract 1 from both sides, then you get x equals 4. Are we doing okay? Yep.
Well, like on pre-2 on the second line, why do we put x equals 5 twice?
Because one side comes from pre-1. Pre-1 expands to this one here. This one comes from the structure. Yeah, I'm not combining steps, so that's why I'm going to spell it all out, and then we simplify it. Okay, so the other side, which is 4, line 4, is about the same. It's just the flip side of this. So we can say pre-4 is the same as pre-1, and not the case that x equals 5, because otherwise we would not be about to execute line 4. Pre-1 is saying x equals 3 or x equals 5. And, okay, I need parentheses in this case. It is not the case that x equals 5 means x does not equal to 5. And we can simplify this using the same trick again. Okay, if one side is completely contained within the other side, we can just choose the one side that is the more restrictive. Can I apply that rule in this case? I can't. I really cannot, because x is different from 5 versus x equals 3 or x equals 5. They do not, one does not contain the other one completely. Okay, so I cannot actually do that. Intuitively, most people can come to the conclusion and say, well, one side can be 3 or 5. The other side says cannot be 5, and because it's a conjunction, that means x has to be 3. Okay, so intuitively you can do that. But if you don't want to do this intuitively, what you can do is to use the distributive law in Boolean algebra. So now you end up with two conjunctions, and each conjunction has a, excuse me, I take it back. You have two sides of a disjunction, and each side of the disjunction is a conjunction. And what you will find is one of the sides is false. Okay, so you will have only one side left, and the one side that is left will say x equals 3 and x is different from 5, which simplifies to just x equals 3. So I'm not going to go through all that steps because we are running out of time. I have 30 seconds left. Okay, so post 4 would use the substitution rule. I'm going to save myself all the justification here. So it's based on the precondition of line 4. We replace all occurrences of x by f prime applied to x here, but this time f prime is the other one. So this is x equals 3, and f prime of x is x minus 1 in this case, because the right hand side is adding 1. So we do the actual substitution. It becomes x minus 1 equals 3, and if you add 1 on both sides, you get x equals 4. And then post 5, by the structure of a conditional statement, is post 2 or post 4. This part has to do with the structure of a conditional statement. But knowing that is good, because I can now just say, oh, post 2 is x equals 4, and post 4 is also x equals 4. Okay, I'm going to give you this big challenge here. Can we simplify this? Yep, exactly. Here we go. So starting with the answer of going backwards, I can now go forward, but using all the formal steps and come to the same conclusion. All right, so I'll see you guys next Tuesday, and have a nice weekend. Sorry?
The homework's due on Tuesday as well?
Yep, the homework is due on Tuesday.
You said we won't be able to add the class today?
Yes, today and tomorrow will be the last day the dean will sign off those forms.